Hello everyone, my name is Manuel and today I will go over this physics problem of induced magnetic field. So we're given a circular steel loop of radius 75 centimeters, which is at rest in a uniform magnetic field as shown in the figure. The field is changing with time according to B of t is equal to 1.4 teslas times e to the power of negative 0.057 seconds times t. For part A, we're asked to find the EMF induced in the loop as a function of time. So we're given the formula of the induced EMF, which is the rate of change of magnetic flux with respect to time. Magnetic flux is equal to BA times cosine of theta. And theta is the angle between the normal vector and the B field. So the normal vector with the loop forms a 90-degree angle, and the B field is a 60-degree angle. So we're gonna subtract 90 minus 60, and we get 30 degrees. So theta is equal to 30 degrees. Now, we can take out the area and the cosine theta because they are constants. So we're taking the derivative of the B field. After we take the derivative of the B field, we just bring 0.057 on the bottom along with the negative, and we get 0.0798. And because we have a negative on the front, it's gonna become positive. And the area is a loop, so it's pi r squared, and it's a 0.75 meters times the cosine of theta. And we get an answer of E is equal to 0.22 times E negative 0.057 T, which is in seconds, and then the volts for the units of the EMF. For part B, we're asked to find the induced EMF when it's equal to 1/16 of its initial value. The initial value is going to be given at time t is equal to 0 seconds. So we're gonna plug in a 0 on the t, and we're gonna get a value of E is equal to 0.122 volts. And then after we find the initial value, which is this one, we're gonna divide by 1/16, and we get 7.625 times 10 to negative 3 volts. Because we already know the value of 1/16 of its initial value, we can replace this equation with, we can replace this value with the original equation. So we're gonna get 7.625 on the left side and the original equation on the right side. Now we can figure out, now we can solve for the time. In order to solve for the time, we take the ln of both sides. The ln and the E become a 1, and we get negative 0.057 T and the ln of the 6.25. So we divide by the time, and we get 48.6 seconds for the answer for part B. For part C, we're asked to find the direction of the current induced in the loop viewed from above the loop. According to the B field given, we can see that it has an e to the power of negative t. So it's going to be a decreasing graph. Therefore, the B field is going to be decreasing with time. And because the B field is decreasing with time, we're going to have the loop making in counterclockwise direction so that it can make a B field in the same direction that of the outside field, which is going upwards. So if we take the right hand rule, we have the direction of the current going clockwise, and we're gonna have the B field pointing up, so it's gonna be in the same direction. So that's it for today. Thank you.